Ready?
Yes.
Okay, we're now near the summit of Sugarloaf Mountain, and all of the rock around here is the Sugarloaf Formation or Sugarloaf Quartzite, which is a nice, clean, almost 100% quartz sandstone, which has been metamorphosed to a low grade. And this was shallow water stuff. It was shallow water stuff, and it was what the geologists call very mature. That is, any minerals, such as even feldspar, that were at all unstable were broken down. Only the most stable remained. And that, of course, is quartz. It's the only really common mineral that is utterly stable. Give it a billion years and it'll go away. But we don't have that much time. This little slab here is one of the best I've seen in the mountain that shows that this was a nice shallow water environment because it has current ripples on here. The water was moving gently in this direction and moving the sand along, which was deposited in little ripples. You've seen these at the beach, where the tide is moving the water in and out. You'll see little ripples in the sand. That's exactly what's going on here. The mountain itself, this is, as I said at the last place, is the core of an anticline, so the oldest rocks are pushed up to the top. And this is even less likely to have fossils than the other one. However, this sandstone here is almost identical to the sandstone that you find just across the valley on the east side of the Blue Ridge, just on the other side of the Frederick Valley. And above that, you find the same sort of calcareous rocks that we saw down below, which actually lies directly above this, in spite of the fact that we've gone up the hill. And those rocks actually contain fossils. So you can put a number on those. And those are basal Paleozoic rocks, Cambrian rocks. These, since they're so similar to the rocks over there, and are also found at the lowest place in the sequence, these are also assumed to be Lower Cambrian. You can make that assumption. Now, is that assumption a good assumption? I remember the geology that I learned when I was going to school in Boston. The Boston Basin is filled with clastic rock, conglomerates, sandstones, and shales, but they never found any fossils in it. They're low-grade metamorphic or not metamorphosed at all. Just to the south, separated by only a couple of miles, is the north end of the Narragansett Basin, which is centered in Narragansett Bay in Rhode Island. Almost exactly the same rocks, conglomerates, sandstones, shales, except that they contain some coal beds with fossils that put a good date on it. And when I was going to school in Boston, they said that the rocks in the Boston Basin were presumably Carboniferous, or same age as the rocks in Rhode Island. Not unreasonable at all. Until it turns out that there are some volcanic rocks in the Boston Basin. And those volcanic rocks contain fossils. No, they contain zircon. And the zircon can be dated radiometrically. And it's 500 plus million years old, which is about 250 million years older than the coal-bearing rocks in Rhode Island. So it's pure coincidence that the rocks in the Boston Basin look almost identical to the rocks in Rhode Island. For that reason, I always take it with a grain of salt when someone says, but these rocks look so similar to the rocks over there. This is separated by a couple of different thrust fault zones. This has moved quite a few miles. This was not nearly as close to those rocks in the Blue Ridge as they are right now when it was laid down. So saying that it's so close and so similar is a little sticky. Now, if you want me to put a better date on it, I can't. As a matter of fact, I will say that I agree that it is probably the same age as those rocks over there on the Blue Ridge. But I am not going to bet the farm on it. It may indeed be. And there is no, short of fossils, there is no good way to get a date on these. Okay, let's continue up to the viewpoint up there where we'll get to look at some more small-scale geology and a little bit of large scale.